Welcome to our channel. So today we will solve another problem from the chapter Moment of Force. This problem has been taken from the Conscience Physics ICSE class 10. Okay, so just read out the problem. The problem says that there is a uniform meter rule of mass 100 gram which is balanced on a fulcrum at the mark 40 centimeter by suspending an unknown mass at the mark 20 centimeter. So first of all, let us draw the figure. So what will be the figure like? Okay, so uniform meter rule. Let us first draw a uniform meter rule. So consider this to be an uniform meter rule. Okay, fine. This is a uniform meter rule. Okay, now it has been said that it is balanced at the its mass is 100 gram, is balanced at 40 centimeter mark. So it has been balanced on 40 centimeter mark. So the midpoint will be somewhere like here. Okay, and we can say that the 40 centimeter mark is somewhere like this. Okay, so the 40 centimeter mark will be like this. Okay, fine. So this is the 40 centimeter mark where the fulcrum has been placed and the meter rule has been balanced. Fine. Okay, so this is the 40 centimeter mark, and you know that the mass of the rule acts to the midpoint, isn't it? So midpoint means the 50 centimeter mark. Fine. So the weight of the rule, that is the 100 gram, will be acting through the midpoint or the 50 centimeter mark. So somewhere like here. So at this point, the mass of the rule will be acting. So the mass of the rule has been mentioned as 100 gram. So this is the 50 centimeter mark. Fine. Now it has been said that the mass is 100 gram. So if I consider that the mass is 100 gram, then weight of the rule will be 100 gf. So I can write here the force that is acting at this 50 centimeter mark is 100 gf. Definitely you can write it like this. Okay, fine. Now, so what can we say? That now there has been a okay, so this is 40 centimeter. Just let me rewrite it once again. 40 centimeter. Okay, fine. Now it has been balanced by an unknown mass at mark 20 centimeter. So there has to be an unknown mass at 20 centimeter mark. So unknown mass is of 20 centimeter mark. Unknown mass. So here it is 40. Its half is 20, somewhere like this. So here a unknown mass of m gf. Let us consider if it is mass is m gram, then you can say the force is m gf. So this is 20 centimeter mark acting at this point. So the figure is something like this. Fine, isn't it? Okay. Now it has been asked that the uniform meter rule is balanced at this condition with the mass and the mass of the scale. Now it has been asked that what will be the value of the unknown mass small m. Okay, so for this we need to first calculate the, as we know, you have to first calculate the clockwise and anti-clockwise moment. So coming to the first part of the solution, so this is our solution, sorry to mention. So this is the solution of the problem that we are discussing. Okay, so the sort of what you have to do, you have to first find out the clockwise and the anti-clockwise moment. So the clockwise moment will be generated by the mass of the meter rule, that is the weight of the meter rule, that is 100 gf. This will produce the clockwise moment. So you can write clockwise moment due to 100 gf. Okay, so what will be its value? Its value will be 100 into the distance is 50 minus 40, that is equals to 100 into 10 means 1000 gf centimeter is the clockwise moment. Now coming to the anti-clockwise moment, ACW moment, anti-clockwise moment due to the mass m, mgf. So what will be the anti-clockwise moment? Calculating, so m into, you can write it as 40 minus 20 that is equals to 20 mgf centimeter. Now as this rule is in balanced condition, so as the rule is in balanced condition, we can say that the anti-clockwise and clockwise moment will be equal. So by the principle of moments, by principle of moments, principle of moments, we can write the anti-clockwise moment and clockwise moment are equal. So we can write definitely 20 m will be 20 m will be equal to 20 m will be equal to 1000 gf centimeter, or we can say that m will be equal to 1000 divided by 20, so it turns out to be 50 50. Okay, so as I have considered here the m to be the, if I consider the m as the mass, then definitely the mass from this equation we are saying getting that the weight of the meter rule is, oh sorry, unknown weight is 50 gf, and the unknown mass will be then 50 gram. Okay, so just let me write the answer. The unknown, if I say the unknown weight, then it is 50 gf, isn't it? Unknown weight is equals to 50 gf, isn't it? And the unknown mass turns out to be 50 gram. Okay, so first part of the solution has been solved. Now let us see what does the next part of the solution says. Let us move on to the next page. Okay, so we are going to part 2 of the solution. So part 2 of the solution, what the question has been asked. Let us see. To which side the rule will tilt if the mass m is moved to 10 centimeter mark. Now see, if the mass m is moved to 10 centimeter mark, this mass m, what are we doing? This mass m is moved to the 10 centimeter mark. So it is moved from here to, say, this point. Another, say, just take another color. It is moved from a 10 centimeter mark to, say, this point, 10 centimeter mark. So now the mass m has been moved to this point, isn't it? The mass remains same, but it has been moved to 10 centimeter mark. So this is 10 centimeter. Okay, then if the mass m is moved to 10 centimeter mark, it has been asked that to which side the rule will tilt. Now when the mass m is moved to the 10 centimeter mark, what will be the moment, what will be the anti-clockwise moment due to the mass m? Just let us calculate. What will be the anti-clockwise moment due to the mass m? ACW moment. Now due to m, due to mass m equals to, what is the value of the mass we have calculated? It's 50, and now the distance turns out to be 40 minus 10, that is equal to 50 into 30, so that turns out to be 1500 gf centimeter. Okay, 1500 gf centimeter. So this is the anti-clockwise movement. Now the clockwise movement has not changed. The clockwise movement, as see from the previous calculation, the clockwise movement was how much? It was 100 gf centimeter, isn't it? So definitely the clockwise movement is now 100 gf 1000 gf centimeter, but the anti-clockwise movement becomes 1500 gf centimeter. So as the, since in this case ACW moment or anti-clockwise moment becomes greater than the clockwise moment, that is the reason why the meter rule will tilt on the left hand side, isn't it? So this side, because this side is the mass m suspended, so the rule will tilt on the left side of the figure as the anti-clockwise moment is greater. And how much it is greater, we can now you can see it from here. If we just subtract the anti-clockwise and clockwise moment, so the net moment, now net moment net moment is equal to 1500 minus 1000 minus 1000 gf centimeter. So that turns out to be 500 gf centimeter. Okay, isn't it? Yes, fine. So this is the net moment and it is in the anti-clockwise direction. ACW. ACW. Okay, fine. Now, so the second part of the question says to which side the rule will tilt. So the rule will tilt on the left side of the figure if the mass m is moved to the 10 centimeter mark. And the resultant moment is 500. So this is part 3. So part 3 is the resultant moment, hence the resultant moment is nothing but 500 gf centimeter anti-clockwise ACW. Okay, and in the previous question you must write, since the anti-clockwise moment is greater than the clockwise moment, therefore we must write it here, therefore rule will tilt on left side. Okay, sorry that I didn't mention it here. The rule will tilt on the left side. Now the fourth part of the problem, what does it say? The fourth part of the problem, just see what does it say. It says that how can it be balanced by another mass of 50 gram. So definitely when the mass m is shifted to 10 centimeter mark, the anti-clockwise moment is greater. So the mass of another 50 gram, as it has been asked, must be definitely placed where? It must be definitely placed on the right side, isn't it? So just consider the mass m is placed at some distance of say x from the fulcrum on the right side. Mass m, sorry, 50 gram, mass 50 gram, additional mass of 50 gram. So I can write the force to be 50 gf, isn't it? As the mass is 50 grams, so I can write the force to be 50 gf, isn't it? Okay, so I can write it like this. 50 gf. Now what will be the additional clockwise moment generated due to this 50 gf? Okay, so you can say that additional clockwise moment due to the 50 gram is mass is, what will be value? 50 into, we can write x, as because we have considered the distance to be x and not the mark, so it turns out to be 50 x gf centimeter. Now according to problem, this 50 gf 50 x gf centimeter will balance, that is balance the extra 500 gram gf centimeter anti-clockwise moment. So I can write according to the problem as it has been said, my 50x this moment will be equal to the extra 500 gf centimeter anti-clockwise moment. So the value of x will turn out to be 10. Hence the balance must be the weight must be, the additional mass 50 gram must be placed at a distance of 10 centimeter from the fulcrum. 10 centimeter from the fulcrum. In other words, you can write 10 centimeter fulcrum, or you can also write it like this. So the 50 gram mass should be placed at 10 centimeter from fulcrum on right, isn't it? From fulcrum, it has been already shown in figure that we are putting it in right. Okay, so we are putting it in right side. So fulcrum, okay. So fulcrum on right, or you can also write it like this, that it should be placed at 40 plus 10, so 50 centimeter mark, isn't it? 40 plus 10, so it's 50 centimeter mark. So you can also write it as should be placed, or you can write, or it should be placed at 50 centimeter mark, isn't it? You can also write it like this. Okay, so this is your answer. So I think the problem is clear. So this was not so difficult. This was quite an easy problem. We have to just focus on the main principle, that in balanced condition total clockwise moment is equal to the total anti-clockwise moment, and from that we can solve the problem. So I hope this problem is clear. So the problem that we have been discussing about on from the chapter moment of force. So I think these three problems that has been discussed will help you in solving the remaining problems. In the next class, we will be discussing some problems from the chapter work energy power. So till the next video, let us bid goodbye, and please do study well. Take care. Okay, thank you.